Okay, we're going to use a really basic example to help remind you guys of what we started talking about yesterday with dimensional analysis. And in this particular one, we're only going to convert one unit. We're going to do a really simple one. We're going to do 390 grams, and it wants us to turn it into pounds. So we're going to do 390 over 1 so that we can use dimensional analysis, because it kind of needs to be in the form of a fraction, even though we don't have anything on the bottom like the example we did yesterday. And they were nice enough to give us the unit multiplier that we're going to need in order to be able to solve this one. And in this case, it's 1 pound equals 454 grams. So let's see what we remember from yesterday. I'm going to multiply this 390 grams by this unit multiplier. Can somebody tell me why it's going to be okay for me to do that? Why I'm technically not changing the value? Because 1 pound over 454 grams, that sure looks like I'm going to be changing the value if I multiply it. So how come it's not going to actually change the value, Mason? It's basically just a giant souped up one. It's the same way that you guys can do like 25 over 25, and it simplifies to 1 because you've got 2 equal amounts on top of each other. Because, and this isn't something you have to have memorized, so as you can tell, some of you guys might start to stress out about that. All of the unit multipliers that you're going to need to solve anything on your homework and on your test, I'm going to give to you guys. So you're not going to have this stuff memorized. I just want to make sure, and that's what we really do in real life. I mean, the chemist does not have all these memorized. In real life, if the guy working in the chemistry lab needs to change 390 grams into pounds, he goes and looks up what the multipliers are. Okay? In real life, you don't memorize that stuff. So I will give you all the ones you're going to need to know. So we've got a unit multiplier of 1 pound over 454 grams. We can do that because they're 2 equal amounts. So basically, this is just a giant souped up 1. Now, 1 pound over 454 grams, and we're just going to multiply it together. Now, somebody tell me exactly why I set it up and I'm multiplying it like this instead of, because I could have just as easily done 454 grams over 1 pound, but there's a specific reason why I had to set it up like this. What is it, Hannah? Exactly. When we're multiplying fractions together, like 1/2 times 2/3, the only way I can cancel those 2's, the only way I can cancel those 2's is if one is in the denominator and one is in the numerator. If I had set up my unit multiplier the other way so that the grams were both in the numerator, I wouldn't be able to cancel. And the whole point of doing this is to be able to cancel out the grams and leave the pounds behind. So the grams are canceled. So all that's going to leave us with is 390 times 1, which of course is just 390 pounds. In the top, 1 over times 454 is just 454. So now we're going to divide 390 by 454. What do you get? Oh, I'm sorry. Yep. Okay, so Morgan, what's 390 divided by 454? 0.9. If we're just rounding to the nearest tenth, so if you're just rounding to the nearest tenth, it'll be, so it's going to be 0.9 pounds. To convert, if you convert 390 grams to pounds, it's going to end up being 0.9 pounds for your final answer. Okay, the question was just asked in class if you could go ahead and do some canceling with the numbers first, since 2 goes into 390 and 454, and absolutely you could, but since you're only really dealing with one number here and you're allowed to use a calculator, it's going to be probably just as fast to not cancel beforehand, but absolutely you could just do 390 divided by 2 and cancel along with the 454. Okay, I want you to try this one on your own using the one that we just did a second ago before lunch. Okay, so using this one that we just did as an example, I want you guys to try doing this one on your own. For those viewers at home, I will go ahead and hit the pause button, try it yourself. And before you do, though, in case you have forgotten from when you've done this before, hopefully you guys know that there's 100 centimeters in 1 meter. That's the unit multiplier that you're going to be using. So I'm going to give you just a second. Don't try to do it in your head. Remember, we're using the easy ones to learn how to use unit multipliers so that when we do the harder ones, you'll know what to do. As you're setting it up, remember that in order for your units to cancel, one of them needs to be in the numerator, the other one needs to be in the denominator. So I'm going to set it up as just 94 meters over 1 because we don't have a second unit in the denominator like we will in our examples in a minute. And the unit multiplier that we're going to use is 100 centimeters over 1 meter. So remind us one more time, somebody, why is it okay for me to multiply it by this big old thing right here and it doesn't change the value of it? How come that's okay, Kathleen? Yeah, this is still really, at the end of the day, bless you, this is still just a 1. If you take 100 centimeters and divide it by 1 meter, they're 2 equal amounts, so it's just a giant 1. Now, somebody else remind me, let's see, Elena, how come I had to set it up so that the meters are in the denominator? Exactly, because if the meters had been up here, you can't cancel straight across. So I'm going to cancel first thing. That's also a good way when you've got more than 1 unit to cancel. If you cancel all the ones that you can and you're left with what you're shooting for, you know you probably set it up right that way too. That's another great thing about dimensional analysis. Once you start doing the more complicated ones, it kind of helps you to check yourself. So now we're just going to multiply straight across, 94 times 100. You still got centimeters in the top. Normally you would multiply everything that's on the bottom, but all you've really got left over is 1 times 1, so that would just end up being 1. So you've just got 9,400 centimeters. Should have been your answer. Let's start again. So the question was just asked in class a second ago. In this one, I ended up doing nothing but multiplying, but in this one, I ended up having to divide. And they were wondering how it worked out that way. And that's the really great thing about dimensional analysis, because there are a lot of rules. Because if you're going from a smaller unit to a bigger unit, usually you end up having to divide something. So see how we're going from grams, which are teeny tiny, to pounds? A gram weighs about as much as a paper clip. And then, of course, a pound, we know about how much, that a pound weighs about half your textbook or something like that. So you're going from something smaller to bigger, so that's why you end up dividing. But here we're going from something bigger to something smaller, because a meter is like a meter stick. And then, of course, a centimeter is like one of those little teeny tiny things in between. There's 100 of them between each meter. For a lot of people, that's really confusing, trying to remember like when you multiply and when you divide, and that's why somebody actually invented dimensional analysis, because you don't have to memorize all that. You don't have to remember, well, when I'm going from this unit to this unit, I have to multiply. When I go from this unit to this unit, I have to divide, because all you have to memorize is if the meters are up here, you got to make sure they're down here in your unit multiplier. So that's kind of nice. And then like I said before, in real life, the guy in the lab is just going to look this part up. So you don't even have to have that part memorized. So it's just a nice, easy way for you to not have to memorize like when you're going to multiply and when you're going to divide. Does that make sense? You just memorize kind of like one rule instead of having to multiply a whole bunch of them. But the short answer is basically whenever you're going from something smaller to something bigger, you're going to end up dividing. Whenever you're going from something bigger to smaller, you end up multiplying. Okay. Okay, let's try another one that's got a unit in the denominator. So this time, it's 40 miles per hour. This is more similar to the one we were doing yesterday. And we're going to turn it into feet per second. And they give you the unit multiplier that you are going to need in order to be able to solve it. So the unit multiplier that we're going to use is 1 mile equals 5,280 feet. So, which one's going to go on the top, a mile or the 5,280? Which one's going to go in the top for me to use, Andy? Yep. How come the 5,280 feet is going to go on the top? Exactly. In order to be able to cancel out the miles, which is our goal here, and turn it into feet, you got to put them diagonally from each other. One's got to be in the numerator, one's got to be in the denominator. Okay, now we're going to go from hours to seconds. So we're going to use the unit multiplier. So if we think about this, there's 60 minutes in every 1 hour. Then there's 60 seconds in 1 minute. So that means that there's going to be 3,600 seconds in 1 minute. So I'm going to use this unit multiplier. 3,600 seconds equals 1 minute. Which one is going to go into, or I'm sorry, 30 equals 1 hour. Sorry, guys. Oops. Just checking to make sure you're paying attention. Okay, so 3,600 seconds equals 1 hour. So that's the unit multiplier I'm going to use. Which one's going to go in the top, the 3,600 seconds or the 1 hour? Which one is going to go in the top, Morgan? The 1 hour, so that we can cancel. Since hours are in the denominator here, hours have to be in the numerator here, which leaves the 3,600 seconds in the denominator. So now you've got a couple of different options. You can start canceling, because if you look at that, because that 40 and that 3,600 is kind of screaming at me, because I just happen to know off the top of my head that 40 goes into 40 one time, and that 40 goes into 3,600 90 times. So there's a little bit of canceling you can do to help yourself out so that you're dealing with smaller numbers. So to make sure everybody saw that, because the 40 is up here in the numerator, the 3,600 is down here in the denominator. 40 goes into 40 one time. 40 goes into 3,600 90 times. And now there's actually some more canceling you could do also, but just because my brain's starting to hurt, I'm just going to go ahead and multiply straight across. And I can do 1 times 5,280 times 1, which basically is just going to leave me with, all I really need to write is the 5,280. Don't forget about your feet up there. Then you got nothing times 1 times 90 seconds. So now for the grand finale, just divide 5,280 by 90. Can somebody do that for me, please? What do we got? 50 what? 50, yeah, it's 58.6 repeating. The directions say to round to the nearest tenth. So if it's 58.666 repeating and we're rounding this one, that means we're going to round it up to 58.7. Yeah, and I forgot to delete the answer there, so we know for sure that we're right because Ms. Popelka left the answer up there. So it's 58.7 feet per second. Okay, the question was also just asked by somebody a second ago why there's nothing down here next to the hour. And because you guys will notice in the original problem, there's technically a 1 there. We just don't write it because it's understood, just like when you have a 1 for a coefficient or something. So technically there's a 1 there. I did 1 times 1 times 90. Usually when we write them, though, we just leave them out because everybody just automatically assumes that they're there. I should also note, in case you're somebody that just doesn't like to cancel, you didn't have to do this canceling of this 40 and that 3,600. You very easily, somebody get a calculator handy for me so we'll do it the non-canceling way. Pretend that I did not cancel that 3,600 and that 40. So I'm just going to multiply straight across 40 times 5280 times 1 all over 90. So what's the 40 times 5280? 211,200. And then divide it by 90. And then you'll find out you're actually going to end up getting exactly the same answer. If you just multiply everything straight across and then divide by the denominator, you'll get the same answer. Oops, just joking. I forgot I didn't cancel. So divide it by 3,600, and you should end up getting exactly the same answer that we did before. So you don't have to cancel. So for some, I personally like to cancel because I'm from the old school where they didn't let us use calculators a lot. So I like to cancel because I think it makes it easier. But you're more than welcome to just multiply. Once you set up your unit multipliers, you can just multiply everything straight across and then multiply everything straight across the bottom and just divide your final total in the top by your final total in the bottom, and you will still get the same answer. So that is your option. Before we get started with this example, let's make sure that we remember some of the things that we talked about yesterday in class. For example, we talked about something called a unit multiplier. And an example of a unit multiplier might be, say, keep it basic, 12 inches over 1 foot. So I can actually multiply this unit multiplier. It's called such because it has units in it, and we multiply it times things. So I can actually take this unit multiplier and multiply it times, let's just say as an example, 2 feet, and actually not change the value of the 2 feet specifically. How come? How come I can just multiply this unit multiplier times that, and it doesn't actually change the value of the 2 feet, Megan? It's really just a giant 1. It's a giant 1 with a lot of numbers in it. And if we think back to fractions, if you do 4 over 4, 4 divided by 4 simplifies to 1. 3 over 3 simplifies to 1. It's exactly the same concept here. Because 12 inches is the same thing as 1 foot, technically 12 inches over 1 foot is equal to 1. So that is why I can use this unit multiplier to convert these units, but I'm not actually changing the amount of what it's worth. Now, why did I set up the unit multiplier the way that I did so that the feet are in the bottom and the inches are in the top? Because I could just as easily have done 1 foot over 12 inches, and it would still be worth the same amount, but I did it for a reason. What is it, Katie? Exactly. It's got to be the units that are the same have to be diagonal from each other. So if you were doing like 1/2 times 2/3 and you wanted to cancel to make your life easier, well, you can, because here the 2 is in the numerator, here the 2 is in the denominator. If it were flipped and both 2's were in the denominator, you can't cancel. So that's why you got to make sure you set up your unit multiplier so that the units you're trying to cancel are diagonal from each other. If the one you're trying to get rid of is in the numerator, you got to make sure the unit multiplier is in the denominator. So let's take a look at an example that is going to be fairly similar. We're going to start off with a really basic one to start. Okay, we're going to do, let's see, we're not even going to have 2 units in it yet. 70 seconds equals blank hours. Just to make sure we remember, so we're doing a really easy one just to make sure we know how to set up the unit multiplier. So because the 70 seconds, now normally it would be like 70 seconds per hour or centimeters per minute or something like that. But there's only 1 unit here, so you're just going to do 70 seconds and you're just going to stick a 1 underneath it so that we can use the unit multiplier. And the unit multiplier that we are going to use is, let's see, so there are going to be 60 minutes in 1 hour, and there's 60 seconds in 1 minute. So some people may want to set up, you can do this two different ways. If you want to make absolute sure that you're not going to make a mistake, first of all, go from seconds to minutes and set up a unit multiplier where it's 60 seconds below 1 minute in the top. Set it up diagonally so that you can cancel your seconds. And then you have to, of course, go from minutes to hours. So you do 1 hour over 60 minutes. Once again, you're going to cancel your minutes that are in the numerator and your minutes that are in the denominator. Multiply everything straight across the top. 70 times 1 times 1 is simply going to leave you with 70. So don't forget about those hours. 60 times 60 is 3,600. Then for the grand finale, you're going to need to divide. After you've multiplied everything straight across the top and you've multiplied everything straight across the bottom, you're going to have to divide. So 70 divided by 3,600 is going to give you what? 0.01. We'll just round it to 0.01. To 0.01 hours. So it's in 70 seconds is a very teeny tiny fraction of an hour. Record this. So those of you who kind of like to do it in your head might have thought to yourself, okay, so there's 60 minutes in 1 hour, and there's 60 seconds in 1 minute. Ergo, there's 3,600 seconds in 1 hour. A lot of you guys might have just made that jump. So you can absolutely do that. Just do 1 hour over 3,600 seconds. And as you find out, look, you still end up doing 70 divided by 3,600. So you can do that. A lot of you guys can make that jump in your head, and that's completely fine. And you get the same answer, obviously. Some people, though, it really helps them. Some of us just aren't good at making a jump from here to here. It's easier for us to kind of work out every single step. So that's your choice. If you can do this part in your head, then you can just use that 1 unit multiplier. Okay, I'm going to give you guys a minute to try to work this one. It's very similar to the one that we just worked. You're going to convert 37 feet. I just always like to rewrite them down here myself, to centimeters. And you'll notice here they actually gave you the unit multiplier that will help you out, because that's how we do it in real life. When the chemist is converting from one amount to another, he doesn't have all this stuff memorized. He goes and looks it up. So tonight on your homework, I'm going to give you all the unit multipliers that you're going to need, because I'm not interested in whether or not you can memorize that. I'm interested in whether or not you know how to use dimensional analysis. And that's really what you do in real life. It's kind of silly that sometimes you have to memorize that stuff, because you don't really do that in the real world. So take just a second. If you're watching this at home, hit the pause button for a moment. Be close to finished. No? Okay, I'll give. Let's go ahead and set it up. So before you can actually use this unit multiplier and make the step from inches to centimeters, you need to make the step from feet to inches first of all. Now, they did not give you that unit multiplier because it's really kind of assumed that at this level you're going to know that one. So first of all, we're going to do 12 inches over 1 foot. Somebody remind me again why I wrote it this way, why I put the inches on the top. So that I can cancel out the feet. If they were across from each other, I wouldn't be able to cancel. Now I get to use this unit multiplier, which is 1 inch equals 2.54 centimeters. Which one of them is going to go in the top? Centimeters or the inches? Which one, Sophie? The centimeters, exactly. So we do 2.54 centimeters over 1 inch so that we can cancel those inches. Another great thing about dimensional analysis is that it helps you to kind of check yourself, because you know after you do all your canceling, if you end up with centimeters in the top like you're supposed to, you know you probably set it up correctly. Now all we have to do is multiply straight across the top. We don't have any, we can't cancel any numbers because we don't have any numbers in the bottom, so we're just going to multiply them. So 37 times 12 times 2.54. Multiply all that together, and you get, is it 1,127? So 1127.76. We'll round it to 0.8 because I think the directions say to round it to the nearest tenths. And of course, don't forget your units should be centimeters. So now we're going to take a look at one that involves two different units instead of just one. And we've got to convert pounds per kiloliter, which is what that is, to grams per milliliters. And I always like to rewrite them just like so. Remember that technically there's a 1 right here. It's 1 kiloliter. We just don't write it because it's understood. And for no particular reason, I'm just going to take care of the pounds first. Technically, you can use a unit multiplier to get rid of anything. Honestly, I could use the unit multiplier to get rid of the kiloliters first. I'm just choosing the pounds. And they give that one to us. There's 1 pound for every 454 grams. So I'm going to set up my unit multiplier. Which one's going to go on the top? 1 pound or 454 grams, Taylor? 454 grams is going to go on the top. 1 pound is going to go on the bottom because the pounds can cancel that way. So now I've got the grams that I'm looking for that I need in my problem. Now I've got to go from kiloliters to milliliters. Now, hopefully this is something that you remember from when you guys were in 6th grade, but just in case you don't, there are 1,000 liters in 1 kiloliter, and there are 1,000 milliliters in 1 plain liter. I'm going to make this with a capital L even though that they don't, so we're actually going to have to go through 2 different steps to go from kiloliters to milliliters. So the first one we're going to do is use this one right here. There's 1,000 liters in 1 kiloliter. Which one's going to go on the top, the 1 kiloliter or the 1,000 liters? Which one's going to go on the top, Megan? The kiloliters, because the kiloliters down here need to be canceled. So for 1 kiloliter, there's 1,000 liters. I'm going to cancel my kiloliters. Now I'm going to go from liters to milliliters, because that's what I need in my problem. So there are 1,000 milliliters in 1 liter. Which one's going to go in the top, the 1,000 milliliters or the 1 liter? Which one's going to go on the top, Joseph? The liter, because I got to cancel out this liter. So 1 liter equals 1,000 milliliters. Cancel. Now, before you start multiplying, check out. This is something, what I was talking about before, that's pretty cool about dimensional analysis. I'm looking for grams in the top, milliliters in the bottom, according to the answer I'm looking for. Look, I've got grams in the top, milliliters in the bottom. See, now that's not 100% guarantee that I did it right, but it's at least something that makes me feel a little bit better, like, oh, I probably set it up right. So now we're just going to multiply straight across. We're going to do 4 times 454. Don't forget about your don't forget about your grams that are up at the top. Over 1 times 1 times 1,000 times 1,000 is going to give you 1, 2, 3, 4, 5, 6 zeros. So that's going to be over 1,000,000. This is going to be a pretty little tiny number we're talking about here. So when we do 4 times 454, what did we get? Joseph? 1816. We're going to divide that by 1,000,000. And what did you end up with, Phoenix? And he's absolutely correct. This is a little trick for you. Just do it in your head. When you're dividing by something that has nothing but zeros in it, you just take the decimal point. Technically, the decimal's there at the end, and you move it to the left however many zeros there are. So you go 1, 2, 3, 4. Oh, you're out of numbers. 5, 6. That's why there were 2 zeros in the front. So Phoenix was absolutely right, and I can tell without a calculator. So it is 0.001816 grams per milliliter. Any questions? Now, okay, we're going to stop for just a second for those of you that are doing it at home as well. So this is the answer that you should have gotten. And somebody in class just said their calculator gave them the answer of 1.816, and there should be something after it. There should be something else on there too. It's like it probably says something like to the negative third. Okay, and it says to the negative third. Okay, this is something you guys are going to be learning about in science class really soon. At least Ms. Zotto told me you were. It's called scientific notation. And it's basically, instead of writing really super small numbers like this, that negative 3 tells you that your answer is really this, move to the left 3 times to make it smaller. That's why it's a negative. Yeah, you guys have probably never seen that before. So if you get something that looks like that, all that means is that little negative 3 that's hanging out there in outer space, it tells you to move your decimal point over 3 places, and that's the actual real answer. Okay, sometimes they do it the opposite way too. If your answer turns into a really big number, you might see something like this in your calculator, like 1.1, and then you might see like a 9 up in the corner. It's like a little exponent. That's telling you that the real answer should be moved over 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And that the real answer is a whole number with all those zeros after it. So that's called scientific notation. And you should be talking about it in science class, especially when you start talking about like how far away the planets are from each other. That's a lot of miles, like a whole lot of miles. So rather than deal with those big, huge numbers like that, a lot of the time they just use scientific notation like that. Except you'll also see them do, sometimes you see it instead of just, your calculator just puts the little 3 at the top, but true scientific notation will look something like this. It'll look like 1.816 times 10 to the negative third power, because that's technically what you're doing, is you're dividing it by 10, it's like in the negative direction. But it means the same thing. If you see it times 10 to this power, it just means you move the decimal over. That's an important point, because your homework tonight, if you guys are using calculators, you may end up with some little numbers like that, so you guys needed to know that. Great question. Okay, take just a second. Set this one up. Now, just in case you guys don't know, the unit multipliers that you're going, or the unit multiplier you're going to need, there's 5,280 feet in 1 mile. And then the other one you should probably know. So that's how you're going to go from miles to feet. Then to go from feet to inches, of course, you'll do the 12 inches equals 1 foot. So take just a moment, try to set this one up. And I shouldn't have to tell you how to go from seconds to hours. Take a moment, set it up, and we'll work it in just a minute. Set it up. So to set this one up, I'm just going to put my 16 miles per second. I'm just going to put my original problem over here. Now, to get to inches from miles, first I got to turn miles into feet first. So I'm going to do 5,280 feet over 1 mile. Because I should see all eyes overhead. Okay, and the reason I did that is so that I can cancel out my miles. That's why the 5,280 went on the top. Now I've got to get rid of those feet because I'm really after inches. So I'm going to do 12 inches over 1 foot once again so that I can cancel out the feet. If I'd done it the other way, they wouldn't have canceled. So that takes care. Now I've got the inches I was looking for. So I'm just going to go ahead and go straight to, because I know that there's 3,600 seconds in an hour. But I just as easily could have gone from seconds to minutes and then minutes to hours. Now I'm just going to multiply straight across, but I'm going to double check and see, yep, seconds. So if all I've got left, and this is how you can kind of double check yourself, I've just got inches per hour left, so I probably set it up correctly. So I'm going to do 16 times 5,280 times 12 times 3,600. Don't forget about the inches that are left. And then 1 times 1 times 1 times 1. So there's nothing in the bottom except for the hours. So all I need to do is just multiply straight across, and you get a heck of a number if you do that. should be 3, I better double check and make sure. 6, somebody double check me. 6, 4, 9, 5, 3, 6, 0, 0, 0. Yep. And inches per 1 hour.